So what up, this is my second simple machine. It's also a pulley system, but same concept, but this time it uses 3 pulleys instead of the other 2. So let me just show you how it works real quick. You pull it down, and it should pull that thing up. So let me show you how it works. So it's honestly the same as the other one. The tension is a little different though. So again, your ideal mechanical average doesn't take into consideration friction. It's just your input distance, so how much I was pulling down here before, over your output distance, which was how much the bottle was lifting up. I did the measurement, my hand was going down 90 centimeters. Well, the bottle was going up 30 centimeters, which equals an IMA of 3. Another way you can figure that out is using your output force over your input force. So IMA is just a ratio, so the weight doesn't matter much. So we'll just say it's 1,000 newtons down. So because there's 2 ropes pulling, you're actually gonna have to start on top to find your tension. So let's say that's T. This would be T over 2. This would be T over 2. Because it's the same string, there's also going to be T over 2, and this is going to be T. So the bottom, what's actually supporting it is 3T over 2, which is equal to your 1,000 newtons pulling you down. If you multiply that, that's 2,000 divided by 3. Your T, which is up here, is around 666, which means how much you're pulling down here would be 333.3, that's 0.6 newtons. So your output force, which is how much you're hauling up, is 1,000 over your input force, which is how much you're pulling down right here, which is 333.3. That keeps on going. That should equal approximately roughly 3. So that confirms that. Or you could just count how many ropes are holding the bottle up. You have 1, 2, 3, IMA 3, boom. Your AMA, again, you don't know what that is because it takes into consideration friction, and I don't have a Newton scale to see how much force I'm pulling down with, but all you need to know for AMA is it's your resistance load over the actual force you're applying. That takes into consideration the heat loss from friction, the energy loss from heat, I mean. Next is your efficiency. Your efficiency, all that is your your AMA over your IMA. Because we don't know what your AMA is, however, we can assume that it's always going to be less than your IMA, because the ratio of this will always take into consideration friction, so you'll be losing energy, so your IMA ratio will always be greater. So that means what we can assume for efficiency, that it's always going to be less than 100%, because in the actual world you always have friction to deal with. And I forgot to mention, but effort is basically the force you're applying on this string. The force being applied, your input force, is the effort you're doing to move this load.